regulation of kidney function. The function of the kidney is regulated by three structures, that is the JGA cells, that is juxtaglomerular apparatus, hypothalamus as well as the heart. So these three structures are involved. First let's deal with the JGA cells. Okay, juxtaglomerular apparatus or juxtaglomerular cells. Where is it found? This is found by the special modifications of cells present in the afferent arteriole as well as the distal convoluted tubule. When the rate of GFR, when the glomerular filtration rate decreases, the JGA cells will get activated. What it will do? It will first release the renin. Renin is released by the juxtaglomerular cells. This renin will act upon the angiotensinogen which was released by the liver. So what happens to this angiotensinogen? This gets converted into angiotensin 1. Angiotensin 1 gets converted into angiotensin 2. So the conversion of angiotensin 1 to angiotensin 2 is done by this angiotensin converting enzyme. Okay, now the angiotensin 2 has been released. What happens next? The release of this will make the vasoregions to be constricted. So the capillaries and everything will get constricted. So that is called as vasoconstriction. So what happens if you want to take the water to the first floor of the house? The pipe will be very narrow. It won't be wide. Why the pipes are narrow if you want to take the water to the upper region of the house? That is because as the diameter decreases, the pressure can increase in that region. So it leads to vasoconstriction, as well as the release of aldosterone. Release of aldosterone which will stimulate the reabsorption of sodium as well as water. So as these mechanisms undergo, so what will happen? Here what happened? The GFR, glomerular filtration rate, was less. Now because of the vasoconstriction and reabsorption of sodium and water, the blood pressure will increase. As the blood pressure increases, glomerular filtration rate will also increase. Next is with the hypothalamus. When there is low body fluid, hypothalamus will stimulate the osmoreceptors. To release ADH, antidiuretic hormone, or the vasopressin. From where it is released? From the adenohypophysis, from the anterior part of the pituitary gland. So hypothalamus will get stimulated when the body fluids is being decreased, which will stimulate the osmoreceptors. Then the osmoreceptors will give signal to the pituitary to release the ADH and vasopressin from the anterior pituitary or the adenohypophysis region. Again what happens? The same thing. Here it happened to the vasoconstriction. Here also it will lead to the vasoconstriction, as well as reabsorption will increase in the distal convoluted tubule. So now the reabsorption increased, so which will prevent the process of diuresis. So what is meant by diuresis? The passing of excessive water is called as diuresis. Here I said blood fluid has been decreased. So if diuresis is prevented, then obviously the blood fluid level will increase. And when the body fluid will increase, this will give the feedback to the hypothalamus to stop secreting this ADH and vasopressin, because obviously the body fluid has now come into balance. Last is with the heart. So these two are working in vasoconstriction to increase the blood pressure and the glomerular filtration rate. But sometimes this increase will lead to the increase in the blood flow, increase in blood flow to the atria of the heart. When there is increase in blood flow, obviously the pressure will be there. So this need to be regulated. This should be brought back to the control. That is done by the release of ANF by the heart, that is atrial natriuretic factor. So when the atrial natriuretic factor is released with love from the heart, what it will happen? It will lead to the vasodilation. So when vasodilation occurs, what happens next? Obviously, here it was vasoconstriction. Now it is vasodilation. So the pressure through which the blood was coming to the heart will be reduced. So can we say that when there is vasodilation or when there is hypersecretion of the renin for vasoconstriction, if it is causing any extreme pressure on the atrial walls, then the release of ANF will produce a check to the JGA cells, that is a juxtaglomerular apparatus. So we can say that the ANF factor is also, whenever it is released, is also controlling the release of the renin if the renin release is increased. So here this gives a check to the juxtaglomerular apparatus, and the word RAAS stands for renin angiotensin aldosterone mechanism, because angiotensin, it is acting on that, as well as aldosterone is released, which is mainly causing the reabsorption of sodium and water. Thank you.